Hello guys. So today we are going to be looking into polar bonds and polar molecules. Now I'm going to be writing with every other color except blue. Okay, so whenever I write with blue, just note that that particular word is a keyword that you need to pay close attention to, especially when you are preparing for your examination. Okay. So now, but before we dive into polar bonds and polar molecules, we need to understand a concept known as bond polarity. Okay, now what is bond polarity? Uh, Before now, we have discussed covalent bonding, right? And we know that in covalent bonding, two atoms came together to share electrons, right? And the thing is this: most of the covalent bondings, the electrons are not evenly shared among themselves, among the two atoms, and this is as a result of what we call electronegativity. Okay, now the thing is this: the all atom has what we call electronegative value. So the difference in this electronegative value is what results to uneven shed of electrons, and that is what bond polarity is all about. Now, what is electronegativity? Now, electronegativity basically is the power of an atom to attract the electron pair in a covalent bond towards itself. Okay. Now, different atoms have different, you know, electronegative value. Okay. So, and this power is different for every atom depending on the size. Okay, depending on the size and nuclear charges. Okay, and there's a trend of electronegativity across in the periodic table, and you also have to take note of that and pay attention to that as well. Now, in the periodic table, electronegativity increases along the period, and this is as a result of the as a result of the increase in atomic radius. Okay, the increase in atomic radius. Okay, as atomic radius increases, then down the group, the electronegativity decreases down the group. And this is as a result of the increase in shielding. Okay, this is a result of increase in shielding. So you have to take note of um, this concept. All right. So polar bond are formed as a result of large difference in electronegativity. Okay, when you have large difference in electronegativity between two atoms forming a covalent bond. Okay, so we said to have polar bond. Now there is a table of electronegativity that help us to work out if a bond will be polar bond or not. Um, if the electronegative difference is in the range of between 0.4 and 1.7, the bond will be a polar bond, right? Now, if the electronegative value is greater than 1.7, it is no longer a covalent bond, it's an ionic bonding. Okay, and if the value is below 0.4, that is less than 0.4, then it is not a polar bond. It is a non-polar bond. But it's still covalent bond though, but it's a non-polar covalent bond. I hope that makes sense. So now let me expatiate more on this using visual representation. Let's say we have two atoms of the same kind, X and X. Since they have the same type, it means they have the same electronegative value, right? Now, if they involve in covalent bonding, the electrons are going to be shared equally among themselves, okay? Because the electronegative value is zero, basically, right? So in this case, we have a non-polar covalent bond. Okay, example can be seen in bond in between the atomic element. For example, chlorine. Now, two chlorine atoms combine to form chlorine molecule, right? Also, oxygen. Two oxygen atoms, okay, bonded, shed electrons to form oxygen molecules. Let's say another example, we have two different atoms, X and Y, and one of them is more electronegative than the other. Let's say Y is more electronegative than X. So Y is going to have a partial negative charge, while X will have a partial positive charge. This shows that the electron density is more towards Y. Okay, now I'm going to draw this to represent the electron density. Okay, and it should show that there is more electron towards Y than X. All right, so now in this case we have a polar covalent bond. A polar covalent bond. Example can be seen in hydrogen chloride, okay, water, CO2. Okay, so these are two different atoms with different electronegative value. So the net electronegativity, there is a large difference in the net electronegativity between these two atoms. So hence we have polar covalent bond. Let's say we have another atom X, right? This X is positively charged, and we have atom Y. This Y is negatively charged. Now remember, this is not partially, okay, not partially negative or partially positive. Now in this case, it shows that S give off electrons to Y, right? So Y receive electrons and S give off the electron. In this case, this is not a covalent bond. This is ionic bond. So now what happened here is that the electronegativity difference between these two is greater than 1.7, right? Then, but in polar covalent bond, the electronegativity difference is between the range of 0.4 to 1.7. While in non-polar covalent bond, the electronegative difference is 0. Okay, so that is, and this is called ionic character. Ionic character. As you can see, it increases from non-polar covalent bond to polar covalent bond and then ionic bond. Now, example of ionic bonding, I believe we are quite familiar with this. Example can be seen in sodium chloride when a metal gives off electrons to a non-metal. Transfer of electrons, basically. Okay, I hope that makes sense. Now let's take a look at polar molecules. Now, some might be tempted to think that polar molecules and polar bonds are the same thing, or probably they might think that all polar bonds result to polar molecules. Polar molecules are formed when there is an overall difference in polarity across the molecules, and this is usually due to the arrangement of, the polar bonds and the geometry of the molecules. All right, that is when a polar molecule is formed. So when you have overall difference in the polarity across the molecule, okay, across the molecule, that is when you have a polar bond, a polar molecule rather. Like I said, it is as a result of the arrangement of the polar bonds, all right, and also the geometry of the molecule. Geometry of the molecule. So it means that now all polar molecules are as a result of polar bonds. Okay, but not all polar bonds give rise to polar molecule. So you have to take note of that. All right, now let's take an example. On dioxide, for example, CO2. Now, CO2, the central atom here is carbon, right? And carbon is bonded to oxygen, one on this side and one on this side. As you can see that the geometry of this molecule is straight, right? And we know that there is a polarity between carbon and oxygen, right? That is, oxygen is more electronegative than carbon. So you draw, don't forget, you have to do this as well. You draw your polarity this way. Now these symbols indicate that the electrons are more towards oxygen, and also we have another polarity this way as well. Okay, now because of the geometry of this molecule, this polarity and this polarity will cancel out each other. Hence, this compound is a non-polar molecule. I hope that makes sense. Let's go another example. We have H2O. Now, the oxygen here is the central atom, right? And we have the oxygen, and it's bonded to two hydrogen, and the shape is bent. I've explained that in my previous video. You can check my previous video on shapes of simple molecules. You understand better. Okay, the shape is bent. Now, there is a polarity between oxygen and hydrogen, right? Now, oxygen is more electronegative, so you draw your polarity pointing towards the oxygen, and also this way as well, you draw your polarity pointing towards the oxygen, right? Now, in this case, because of the geometry, there is a raw difference in the polarity across this molecule. Hence, this molecule is a polar molecule. I hope that makes sense. So that is what polar molecule is all about, and that's how to differentiate between a polar bond and polar molecule. The key things, the key words or the key things to take home from here is that all polar molecules are as a result of polar bonds, but not all polar bonds result to polar molecules. And that's where we're going to stop for today. If you haven't done so, kindly subscribe to my channel, like the videos. If you have any question, drop them in the comment section, and don't forget to turn on your notification bell so you get notified whenever a new video like this is dropped. Thank you for watching.